Okay, let's pull back the curtain on something you use every single day, probably without even thinking about it. AI search. You know that feeling, that almost magical ability for it to know exactly what you're looking for? Well, it isn't magic at all. It's actually powered by some incredibly clever and really beautiful mathematics.
I mean, you've definitely felt this, right? You type in just a few words, and the results that pop up are so dead on, it's kind of spooky. So how did search go from just clumsily matching keywords to actually understanding what you mean? That's the puzzle we're going to solve today.
And this example really hits the nail on the head. Think about it. It wasn't that long ago that searching for the view from the tallest building would get you buried in pages about architectural specs and construction sites. But now, the search engine gets your intent. It knows you're not an architect, you're a tourist who just wants to see the skyline. That difference is everything. It's a massive shift from just matching words to truly understanding meaning.
So how did we make that jump? Well, it all starts with completely changing how a machine even thinks about what you're asking. We had to move way, way beyond just looking for words on a page.
And the technology that made it all possible is called semantic AI. This is the real powerhouse, the engine that transforms search from, let's say, a simple filing clerk into a super intuitive research assistant.
So what exactly is semantic AI? Well, in a nutshell, it's AI that finally gets the joke. It doesn't just see individual words anymore. It understands the whole web of relationships and the context connecting them, kind of like our own brains do. It's all about grasping the real meaning behind all the data.
And it pulls this off using a few key tools. It interprets language naturally. It uses these enormous knowledge graphs. Think of them like giant mind maps to connect how concepts like tourist, building, and tickets are all related. And it gets the bigger picture. But maybe the most crucial part is that it can actually explain its own reasoning, which is a huge deal for helping us trust what it's doing.
This, right here, this is the million-dollar question. I mean, it's one thing to say an AI understands meaning, but how do you actually program that? How do you take something as abstract and, well, as human as meaning and translate it into cold, hard code? Well, the answer actually comes from a really old philosophical debate.
For the better part of a century, the folks working on this, the computer scientists and the linguists, were basically split into two opposing camps, and they had two completely different ideas about what meaning even is.
So in one corner, you had what you could call the dictionary approach. These guys argued that meaning is fixed and logical. The word cat simply refers to the set of all cats in the world, period. It's all about precise, formal rules. But in the other corner, you had the context approach, and they said, nope, meaning is fluid. It all comes from how we actually use words with other words.
This great quote from the linguist J.R. Firth just sums it up perfectly. Think about the word queen. When it's next to king and palace, it means one thing. But when it's next to bee and honeycomb, it means something totally different. See? Context is everything. And this is the philosophy that really powers modern AI.
Now, for a very long time, these two worlds, the world of rigid logic and the world of fluid context, were seen as completely incompatible. You just had to pick a side. But then, a mathematical breakthrough came along that changed, well, everything.
Just imagine you have two groups of mapmakers, and each one is absolutely insisting that their map is the only right way to see the world. That was pretty much the state of AI in linguistics. Everyone was working on the same problem, but speaking completely different languages.
The breakthrough came from a proof called a homomorphism. Okay, it's a fancy word, I know, but just think of it as a perfect Rosetta Stone. It's a mathematical guarantee that you can translate flawlessly from one system to the other without losing anything. It proved that these two very different ways of thinking were, deep down, compatible.
So let's see how this actually works. On the one hand, you've got the logical path. You start with the formal concept of a cat. Then you apply a strict logical rule, like is sad. The result is a clearly defined set of all the sad cats that exist in the world. Very clean, very structured. Then you have the AI's path, the context path. Here, a cat isn't an abstract concept. It's a specific point in a giant map of meaning. It's represented by a list of numbers we call a vector. Think of it like a coordinate. And sad isn't a rule. It's more like a mathematical instruction, like move 3 steps to the left. So you apply that instruction to the cat vector, and you land on a brand new coordinate, a new vector that now represents the idea of a sad cat.
And here is the absolute breakthrough, the amazing part. The homomorphism proved that if you start in the same place, both of these paths, the super rigid logical one and the flexible vector-based one, land in the exact same spot. That logical set of sad cats and that final sad cat vector are perfect equivalents. They're just two different languages describing the exact same thing.
Okay, that's a really cool math trick, but why should you care about it when you're just typing into your search bar? Because this connection allows us to build AI systems that truly get the best of both worlds. This is where the rubber meets the road. Because we can finally bridge these two worlds, we get AI that is both incredibly intuitive and perfectly logical. This lets it uncover hidden patterns in mountains of data, deliver search results that feel like they were tailored just for you, and, so importantly, it lets the AI ground its decisions in a way that we can actually understand. It's not a mysterious black box anymore.
So at the end of the day, this mathematical bridge created a kind of hybrid intelligence. It gives AI the common sense intuition to understand what you really mean, but combines it with the rigorous power of logic to reason about it. We no longer have to choose between two different maps. Now we have one unified, incredibly powerful view of the world.
And that leaves us with a pretty fascinating thought to chew on. For the very first time, we have a real mathematical foundation for building systems that can reason with both logic and context, with both structure and nuance. So the question now isn't just about what they can search for, but what they'll truly be able to understand.